Petri dish. Note its temperature. Put it in the fridge for a few hours. Now the water changes into solid ice. Note the change in its temperature. Water molecules take definite shape. Thus, we can say that liquid changes into solid. In liquid state, water molecules in water move and take the shape of the beaker. On heating, the water molecules absorb energy and transfer it to the adjacent molecules. In this way, they get more energy, which is just sufficient to leave the surface of liquid. During the process, the liquid state of water transforms into the gaseous state. This gaseous state of water is called water vapor. Sometimes, certain solid substances directly convert into vapor state without melting. It is called sublimation. Take 10 naphthalene balls and add in a watch glass. Put the watch glass over the wire gauge on tripod stand and cover it with an inverted funnel. On heating, naphthalene balls are converted into vapors, which is deposited in form of solid inside the funnel wall. Thus, we can conclude that solid is converted into gas and vice versa. In a chemical change, a new substance or substances are formed. The properties of the substance change, and this change is permanent in nature. The original substance cannot be obtained. It is illustrated by this activity. Take a test tube. Fill it with water and immerse an iron nail in it and cover the mouth of the test tube with rubber cork. Keep it for a few days. The shining of nail disappears and it is covered with a brown surface. Iron is converted into hydrated iron oxide. Burning of magnesium is a chemical change which can be shown by this activity. Take a piece of magnesium wire and hold it with a tongue over flame. The magnesium burns and leaves white ash. Collect it in a watch glass. The property of magnesium is different from that of magnesium oxide. Another example of chemical change is ripening of fruits. The green color of raw mangoes changes into yellow due to chemical changes. Reacts with silver nitrate to give silver chloride and sodium nitrate. Other examples are given here. Rollover on physical state, specific condition, and precipitate to know about the chemical equations and their physical state, condition, and precipitate. Balanced chemical equation is the equation in which total mass of reactants is equal to that of the products. It is based on law of conservation of mass. Number of each element should remain the same. As you can see in the animation, the number of atoms in both sides is not same, so it is unbalanced reaction, and to balance this equation we will multiply it by 2. As you can see that in both sides of this reaction, number of zinc atom is 1, number of hydrogen atoms is 2, number of sulfur atom is 1, and number of oxygen atoms is 4. So, this is balanced equation. As you can see that in both sides this reaction, number of carbon atom is 1, number of hydrogen atom is 4, and number of oxygen atom is 4. So this is balanced equation. As you can see that in both sides of this reaction, number of sodium atom is 1, number of chlorine atom is 1, number of silver atom is 1, number of nitrogen atom is 1, and number of oxygen atom is 3. So, This is balanced equation. Let us try to balance the chemical reaction as given here. First, counting the number of various elements on both sides of the equation, there are 3 elements like Fe, H and O. There are 4 O atoms on the RHS and only 1 O atom on the LHS side. To balance water, multiply H2O by 4 in LHS. To balance hydrogen atom, H multiply by 4 in product side. To balance Fe, Fe multiply by 3 in reactant side. Thus, the equation becomes 3Fe plus 4H2O is equal to Fe3O4 plus 4H2.
Balancing of chemical equation. Let us understand balancing of equation for reaction between aluminium chloride and calcium hydroxide by hit and trial method. It can be seen that on multiplying aluminium chloride by 2 and calcium hydroxide by 3 on LHS, a balanced equation is obtained as shown.
Reaction of zinc metal with dilute sulfuric acid is an exothermic reaction. Take a conical flask, add 5 grams of zinc granules and insert a thermometer in it. Close its mouth with a cork fitted with a stopper funnel. Note its temperature. Now add dilute sulfuric acid. The reaction starts immediately. A white precipitate of zinc sulfate settles at the bottom and gas evolves. Now, note the temperature. It rises. Endothermic reaction is shown by this activity. Take a solid barium hydroxide in a beaker. Insert thermometer in it and note initial reading of thermometer. Now, add some amount of ammonium chloride to it. Note the temperature in thermometer. It decreases. Chemical reaction is a process in which some known substances are changed into a new substance or more than one new substance. The properties of new substances are different from the properties of the original substances. Let us explain this activity. Take a test tube containing copper pieces and add 1 or 2 drops of nitric acid. A brown fume is formed. To show that mixing of lead nitrate and potassium iodide is a chemical reaction, take 2 test tubes. Take solution of lead nitrate in first test tube and mark it as A. Note the color of solution. It is a colorless solution. Take potassium iodide in the other test tube. Mark it as B. Note its color. It is transparent. Now, mix solutions of A and B test tube. You will immediately obtain a yellow-colored precipitate. Hold a piece of magnesium ribbon over flame. It burns with dazzling light and leaves white powder. This white powder is magnesium oxide. There are 4 types of chemical reactions. Let us discuss about combination reaction. Take small amount of lime in a test tube and insert thermometer in it. Note its temperature. Add 10 ml of water to it. It dissolves and steam comes out. Now, note the temperature. It rises and forms calcium hydroxide. Thus, when 2 or more reactants combine to form a single product, it is called combination reaction. Ferrous sulfate on heating decomposes into ferric oxide. Sulfur dioxide and sulfur trioxide evolves. The decomposition of mercury oxide is demonstrated by this activity. Take mercuric oxide in a test tube. Note its color. It is white. Heat it over burner. A grey-colored mercury appears. The electrolysis or electrodecomposition of water is shown by this activity. Take a plastic mug. Drill 2 holes at its bottom and fit 2 graphite rods with cork. Connect these electrodes by connecting wire through battery. Put acidified water so that graphite electrodes are covered. Take 2 test tubes and fill them with water and invert them on each electrode. Now switch on the current. After some time, oxygen and hydrogen gas are collected by displacing water in the test tube. When burning stick placed on test tube having hydrogen gas burns with popping sound, and while tube which has oxygen gas helps in burning without explosion. Silver chloride decomposes in presence of sunlight. Its color changes from white to gray. It is an example of photodecomposition. Displacement reaction is shown by this activity. Take 2 iron nails and clean them. Take some copper solution in a test tube and keep it in stand. Immerse 1 nail in this solution. After some time, we observe that its color changes from white to reddish brown. It shows that iron displaces copper from the solution of copper sulfate and ferrous sulfate is formed. Comparing the solution in the test tube, we found that it changes from dark to light green. When sulfate solution is added to barium chloride solution, barium sulfate is precipitated out. Oxidation reduction reaction. Copper powder on heating in presence of atmospheric air forms black-colored copper oxide. When hydrogen gas is passed over this copper oxide, it reduces back into copper. Oxidation is a process in which oxygen combines with a substance. When metals combined to metal oxide, as shown here. Reduction in a process which involves either addition of hydrogen or removal of oxygen. H2 add on the Cl2 to form HCl, as shown here. Similarly, oxygen removes from CuO to form H2O, as shown here.
New iron particles are shiny in nature, but when left in air, they get coated with the reddish-brown powder. This process is commonly known as rusting of iron. In this manner, some other metals also get tarnished. Example, copper gets its green coating and silver get its black coating. When a metal is attracted by substance around it, such as moisture, acids, etc., it is said to be corrode, and this process is called corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and all other objects made up of metals, especially those of iron.
Rancidity. It is a process in which fats and oils are oxidized and food becomes rancid, that is, their smell and taste change.